Okay, so let's get started. We're going to be taking a look in this training module at understanding our torque-based control system within our Gen 3 engine control module programming. This is really critical to understand how it works and how the calibration is processed within the programming so that if you have what's known as IPC wheel torque errors, you know how to deal with them. You know that you can either calibrate the torque and inverse tables, go after the speed density modeling, or potentially going after your throttle body data tables to clear up an IPC wheel torque problem that you have going on. Now, if you're unfamiliar with forward programming, IPC stands for internal plausibility check. So it's going to be taking a look at, in this case, we're talking about the torque-based system and our torque tables. It's going to be looking at what we want to have for a desired torque output from the engine versus what the engine's actually giving us. If we're finding we have an overstep in torque, that's a potential problem, and technically you can get into a runaway throttle situation. So the system is going to start to warn us that we're overstepping the amount of torque that we'd like to have the engine make. And as a result, if we have too much of that overstep happening, we're going to go into a limp mode and we're going to throw a wrench light on the dash, which is essentially putting us into this throttle limp mode. We want to avoid that. We want to calibrate our torque system with the modifications that we've done to our engine so we keep this fail-safe checksum in place and use it to our advantage, but making sure that we have things in line and in order with our tables so that it can work in unison and give us this fail-safe strategy. Because if we get into a situation where we have a runaway throttle, we want to be able to shut things down and go into the limp mode. We don't want to let the engine get into a runaway throttle and potentially cause us to crash. So if you're calibrating customer vehicles, you absolutely want to keep your IPC checksum in place. You do not want to turn it off. I see a lot of tuners do this. They just simply turn it off because it's more work to try to calibrate the system and make it work correctly. But it is a huge potential liability that you're putting yourself at risk because somebody crashes their vehicle. If somebody knows what they're looking at in the engine control module programming, they're going to be able to spot this pretty quick and easily point the finger that you went in and turned the checksum off and potentially causing problems. And even if it's your own vehicle, you don't want to be in that situation where you could potentially have a runaway throttle and the engine control module can't shut things down. So I cannot stress this enough. We would definitely want to keep it in place. We want to learn how we can calibrate and tune things correctly. So let's jump in here. Let's take a look at some of the fundamentals. We're going to look at the key tables that are players in the torque-based control system. We're going to be taking kind of a broader overview at this and talking about how the flow of logic works in the tables, and you should have a good idea how the whole system is going to function towards the end of the tutorial. We'll be taking a look in our VCM scanner at some sample data logs, what to look for when a system is calibrated versus when there's a torque reporting or torque modeling problem and we're generating IPC wheel torque errors. So we can actually see both. Let's jump in here and open up a manual transmission stock file to begin our tutorial. We're gonna have to take a look at both a manual and an automatic because our driver demand table, which is where we start the torque request from, is different the way Ford models things based on an automatic or a manual transmission. So let's jump in here. Let's open up a stock manual transmission file to begin. We're gonna go up to File. We're gonna go here to Open. And let's jump in here to our sample calibration file subfolder found in our HPT Gen 3 Coyote main folder. So in here, I'm going to open up a manual file. So let's do 2022 Mustang GT manual stock. And let's go ahead and open this up. Now we're going to move from our engine tab page here, and we're going to go from our general all the way across here under torque management. Under torque management, we're going to have two tabs. We have a general tab and we have a driver demand tab. We're interested in this tutorial is taking a look here at our driver demand tab. Now in here, we're going to find two separate areas. We have a desired torque. We also find pedal characteristics. Now we'll talk about this just briefly, what the pedal characteristics represent. We generally don't edit them, but this can change your pedal plate relationship and feel. This is an easier way to go about trying to calibrate your pedal plate relationship rather than going after and editing your driver demand tables here. But let's talk about this real quick. So we'll see here for a manual transmission file, you're going to have your desired torque known as your driver demand table. Let's start off here for park, reverse, neutral, and first. This represents pedal position, so Excel pedal position. This is what we put our foot on in the car in our drive-by-wire system. So this is the actual pedal assembly. And this is going to be the travel from 1% all the way up here to 100%. Now on the left axis, we're going to have engine speed. So depending on, and this is again, park, reverse, neutral, or first, depending on what it's reporting, if we're in any of those, it's going to use this for the lookup torque. So we see here, let's say we're at 2000 RPM and we're at something like 22.5% pedal input. We'll be requesting here 105.1 pound-feet of torque. So that's what we want to have our engine produce. This is the beginning of our torque-controlled system. Now, what's important to understand about this is the net torque that we want to request from our engine. Net torque is going to be the engine torque minus any frictional losses or pumping losses that can happen with the engine. So this is what we actually want to be able to deliver versus our throttle pedal. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.